Hello and welcome back. Let's learn a bit more about how computers can talk to us. And we're going to be using our good old friend, the 7-segment display. A 7-segment display is like what you see just above me. It is 7 lights arranged in a pattern so that we can represent the numbers 0 through 9 very easily by turning the different lights on and off. Now, each of those lights, each of those segments, in the diagram you can see above me, each of those segments is helpfully labeled A through G. And for a 7-segment display, there are 7 input wires, one for each one of those segments. So if the signal coming in on the wire is on, the segment will be lit. If the signal coming in on the wire is off, the segment will not be lit. And we can see that in action. I currently have the A segment wired up to this button right here. So I can turn the button off, segment goes off, button on, segment goes on. Now, if we look at this diagram again, we're going to focus just on the A segment for right now. And that A segment, you can see, is lit for every number except for the 1 and the 4. So we're going to design the logic circuit for the A segment. If this is green going into this little transmitter, that segment is going to be lit. Now our input is going to be represented by these 4 buttons over on the left here. And between those 4 bits, we can represent every number from 0 to 9. Now, for every number except for 1 and 4, we want that top segment, we want that A segment to be lit. So let's start with the simplest possible case. With the 1 bit lit and nothing else, that's a 1. So we can use our helpful NOT gate to say, if that button is lit, do not light that segment. But if we connect the 4-bit to our circuit using the exact same NOT gate, we end up with a conflict because one NOT is saying yes, the other NOT is saying no. And we can't say both yes and no on a single wire. So that means we have to use a logic gate to look at those 2 wires and decide what the output should be. So in this case, the AND gate is the way to go because we only want the A segment to light up if the number is neither a 4 nor a 1. Now, with the NOT gates and the AND gate arranged in this way, the output will only be lit if both the 4-bit and the 1-bit are off. If either one of them is on or both of them are on, but now wait a moment. If both of them are on, that's no longer a 1 or a 4, that's a 5. So that doesn't work. So we have to add a little bit more logic in order to figure out whether or not both of them are on. Before we go to these NOT gates, let's add another AND here. And this one will light up this wire if both the 4 and the 1-bit are lit. So we can take those outputs and we can combine their results using this OR gate in order to say if both the 1-bit and the 4-bit are on, meaning it's a 5, let it be lit. Or if neither the 1-bit or the 4-bit is on, then it's a 0, so let that be lit. But if one or the other is on, turn that segment off. Rats, I tried really hard to fit this into 3 minutes, but you're just going to have to come back for part 2. Sorry.